Hello everyone, welcome back to another episode of LunchBytes. As always, in today's episode, we want everyone to be aware of others, be welcoming and respectful, be understanding of differences, be patient and friendly, be open to all questions and viewpoints, and be kind and considerate to others. For a full code of conduct or to report an issue, go to aka.ms/eventscoc. I am your host, Annika. Welcome back. I am a specialist at Microsoft, an app innovation specialist. So I look after any conversations regarding GitHub, app modernization, cloud native, or DevOps. Moving on to Tig.
Hi everyone, I'm Tig Brennan. I'm a cloud solution architect at Microsoft UK, and I focus on our digital and app innovation area. So anything focused around our developers, so all things from serverless technologies way up to the DevOps process. That's the kind of stuff that I like to get engaged with. And this is the rest of the team. Steph and Asta unfortunately can't make today's call, but our guest today is a gentleman called Liam. Liam, I've just brought you up on screen with us. Would you like to give us a quick intro to yourself?
Yeah, absolutely. Thanks, Annika. Thanks, Tig. And thanks, everybody, for taking some time to join us either live or on the recording. I'm Liam. I'm an engineer in the app innovation team here at Microsoft. I work very closely with Tig and Annika and the rest of the team. And a big part of my role is working with customers and engaging with developers to help them to get the most out of their cloud investment and their investment in developer technologies. And a big part of that conversation is always around this notion of developer velocity and enabling developer productivity. And we want to make sure that we're doing that in the right way. And that's kind of where this session comes from today, where we're going to be talking about that ability to build effective policies and governance and building out guardrails to enable that developer productivity in a Kubernetes environment. So I wanted to start.
Sorry, Liam. I was just saying before we jump right into the content, and ask for all the audience as we're watching live, you have the opportunity to ask Liam some great questions as well. We will have some time for Q&A as well. So please do get your questions into the live chat, and we will bring those up during the Q&A later in the session. So I'm looking forward to this session. I'll hand back to you, Liam.
Thanks, Tig. So I wanted to start with an illustration here that kind of depicts developer autonomy and its relationship with velocity or developer productivity. And generally, we think that as we increase developer autonomy, as we give developers the freedom in their day-to-day role in the cloud landscapes that we work in, we increase velocity, increase productivity, and in turn, as a result, we increase the opportunity to generate value for our organizations. But we need to do this in the right way. You know, the extremes of autonomy are easy. You know, locking down our environment and restricting access from developers and from application teams is really easy. We remove access. And giving developers full access to cloud environments is also relatively straightforward. But we need to find the middle ground where we are enabling developer autonomy. We're giving developers the freedom to work within the parameters of our organization, to make sure that the actions that are being carried out in the cloud environment is in line with our organization policies, in line with regulatory compliance requirements and more. And this is what brings us into kind of the topic that we're going to be talking about today, which is about building out those guardrails so that when we do invest in developers by giving them that autonomy, we're doing it in the right way without introducing unnecessary risk to our organization. Now, this argument is even more pertinent when we introduce Kubernetes into our landscape. Kubernetes is incredibly complicated, whether we are hosting it ourselves or whether we are using a managed service like Azure Kubernetes service. There's no getting away from the fact that Kubernetes introduces additional complexity to our landscape. Now, managed Kubernetes, Azure Kubernetes service, goes a long way in handling a lot of this complexity for us. And when we think about a lot of the complexity around the Kubernetes control plane, AKS takes that burden away from us as infrastructure engineers and operators. It introduces things like automated upgrades. It takes care of high availability of that control plane. When things go wrong, we have self-healing in place. And it makes it very easy for us to consume Kubernetes, particularly as a developer. But it doesn't go all the way. And we typically say the message we want to land is that managed Kubernetes is only the starting point. When we land Kubernetes into our organization, we have to rethink our end-to-end developer toolchain. We have to rethink our operational processes. We have to rethink the policies and the guardrails that we put to make sure that we're staying in line with those compliance requirements. And these types of questions touch every single pillar of the technology landscape. We have to think about security, developer tooling, platform management, and crucially, DevOps. Now, as you would expect, a managed offering, a managed Kubernetes offering on Azure introduces a number of touch points with our developer toolchain that enable these capabilities. In the security space, first-class and native integration with Azure Active Directory and Security Center. In the developer space, extensions and integration with things like Visual Studio and VS Code, and then on to kind of DevOps and looking at how we enable that first-class experience in Visual Studio, in GitHub, in Azure DevOps, and more. But the focus of today's session is on the integration that we have between managed Kubernetes and Azure policy, and how we can lean on and how we can leverage that integration to introduce those guardrails to enable that effective policy and governance. So a quick introduction around governance with policy. Azure Policy is a service that enables us to dynamically enforce guardrails in our cloud environment. It gives us the ability, natively within the Azure control plane, to control the operations and the actions and the services that we are deploying into Azure. But with the integration with AKS, with Azure Kubernetes Service, we also have the ability to control what's happening within that control plane. The creation of pods, the creation of deployments, the integration with persistent volumes. Now I'm going to start with a quick demo here. I want to start by kind of going through the how do we install this? How do we get started? So over here in the Azure portal, I've got a Kubernetes service here readily deployed. Nothing particularly special about this service. I've deployed it following the kind of the Hello World Getting Started guides that are available on Microsoft Learn. And if I scroll down here on the left-hand side and jump into settings, you'll see that there's an option here for policies. And for this particular cluster, we've already got the Azure Policy add-on already installed and available. And this has done a couple of things in the background that's worth jumping into the cluster to have a quick look. So we can jump over into the terminal here. First of all, let's just quickly verify that the policy add-on is enabled and up and running. And to do that, we can use the Azure CLI. We're going to go and query that Kubernetes cluster, and it's going to come back with the configuration. And we can see here that for the Azure Policy add-on profile, we are currently enabled. Now, what does that mean? If I jump over and have a look in our Kube system namespace, we can have a look at some pods that we've got running in Kube system. And let's just filter this by policy. And we'll see here that there's a couple of pods that have been deployed into this cluster on our behalf. These have been installed, managed, and operated by the AKS add-on. And in addition to these, we also have some components deployed into a namespace called Gatekeeper System, Gatekeeper Audit, and Gatekeeper Controller. Two components from the Gatekeeper open source project that enable us to apply and enforce policies within the cluster, inside the Kubernetes cluster. Now we'll explore how these components work together in a little bit, but before we do, let's jump back into the portal, and we're going to jump over into Azure policy. So Azure policy, it's exposed as its own blade within the Azure portal, and I've already navigated to some definitions within Azure policy. And I've filtered this view by all of the Kubernetes policies that are available. And in this list, there's built-in policies for both the Azure control plane, things that control characteristics of the Kubernetes cluster itself, and also policies that apply to the Kubernetes control plane, things that's happening inside the cluster. We can see a couple of examples here. We can see pods should only use allowed volume types. We can see that Kubernetes services should only be allowed to listen on certain ports. Workloads should not allow container privileged escalation, and more. And in addition, there is also a couple of initiatives, which are groups of these policies, that bring together kind of industry standards of these policies that can be applied to clusters as a group rather than individually. We can see two of them here: Kubernetes cluster pod security restricted and pod security baseline standards. Now, if I jump over into the assignments blade here, we can see that I have Kubernetes cluster pod security baseline standard has been assigned to the resource group that cluster lives in. Now, if I open this up, we can see that it's been assigned, we can see the scope, and if we go and have a look at the definition, we can also see the policies that have been assigned as a result of this initiative. Now we can jump back to the terminal and actually see the effect of that configuration. Because when we are creating these policies, creating these initiatives and assigning them to our clusters, there's stuff happening in the background that's enabling that's enabling the enforcement of these policies. So the first thing that we can do is have a look at the constraint templates that have been deployed into the cluster. And we can see a number of constraint templates that have been downloaded into the cluster as custom resource definitions that are available for us to instantiate and apply to different namespaces and different workloads inside the cluster. We can see a couple of them that kind of relate to what the ones we saw in the list previously. We have kind of no privilege escalation, we've got allow capabilities, we've got no privilege, the allowed ports on services. So these are constraint templates authored by the engineering teams here at Microsoft that are made readily available for us to load into our clusters and start leaning on for that governance. We can have a look at one of these in detail. We can have a look at the constraint template here, and we can see the rego expression that's being used in order to enforce that particular policy. This one here is ensuring that of all of the containers inside the pod, none of them are privileged. Now, rego is understandable. It's fairly straightforward for us to read and understand what's happening. But typically, as we look at scaling policy management within our organization, we don't want to be taking on the overhead of having to author these templates. And having these readily available and authored by the engineering team here at Microsoft makes it much easier for us to adopt and bring into our clusters at scale. So we'll jump back to a couple of slides and understand a little bit behind the scenes around kind of what's happening here. So the first thing that I've kind of mentioned already is that we're talking about two control planes here. We have the Azure control plane, which we think of as the Azure Resource Manager. And Azure policy has the ability to natively enforce assigned policies against ARM. We can do things like ensuring resources are only deployed into known regions. We can ensure that storage accounts have the right encryption configuration. We can make sure that our network interfaces aren't deployed with public IP addresses. All of these things are natively enforced within the Azure control plane. By introducing Kubernetes into our environment, we introduce a new control plane, the Kubernetes control plane. And we're leaning on the Open Policy Agent Gatekeeper project and Azure Policy's ability to synchronize policies into the cluster to handle that enforcement inside that new control plane. We've got a bit of an illustration here to help understand this. At the top, we've got a request coming into the API server. This could be coming from Terraform, this could be coming from the kubectl, this could be us integrating directly using the API. And within the API server, there's a pipeline of components that request is going to go through before the request is executed and persisted into the cluster. First of all, we're going to do authentication, then we'll do authorization with the role-based access control, and then we hit a piece of middleware called admission control. And it's at this point that we can reach out to additional components in the cluster to make a decision whether the request that's come in is permitted or not. So the Azure Policy add-on for AKS installs these two components, the Azure Policy add-on and Gatekeeper v3 into the cluster. The Azure Policy add-on is sat there in the background, synchronizing the policies that we've assigned to the cluster with Gatekeeper. And then when Gatekeeper is doing its work, it's doing the policy evaluation, we're then reporting the compliance of the cluster back into Azure Policy so that we can do policy management at scale from that single view. So when that request comes in, it goes through the pipeline, it hits admission control. We then call out to Gatekeeper to make a decision around whether the request is in line with policy or not. So let's jump back and have a look at this from the developer's experience. So far, we've set the cluster up, we've configured it, we've enabled the Azure Policy add-on, and we've assigned a couple of initiatives to the cluster. And as a result, we can have a look here. As a result, we can have a look at the constraints inside this cluster, or at least we could if I could spell correctly. We can have a look at the constraints, and we can see that a number of those constraint templates have been applied to this cluster. Now, as a developer, I don't necessarily want these guardrails and these policies to introduce friction to my day-to-day role. I want to be able to interact with this cluster the same way as I would previously. And at the points where I hit these policies and where I potentially violate these policies, I need some kind of guidance and some detail around how I remediate and how I move forward with that. So we can have a look at a simple workload here. We'll have a look at pod.yaml, perhaps the most simple of workloads that we could deploy into a Kubernetes cluster. We're defining a pod here. We're using an Nginx image from the Microsoft Container Registry. But crucially, we are asking, or we're requesting, this pod to be deployed, or more specifically, the container to be deployed with a privileged security context. Now, we know from the policies that we set up previously that this would violate that policy. Let's jump back and have a look. Again, we can see Kubernetes clusters should not allow privileged containers. But as a developer, I don't know that. I don't necessarily know that. I don't know that the organization has this stance on privileged containers. Now, I might want to go ahead and submit this into my Git repo. I might have a pull request and have a peer review with a colleague who might point that out to me and say, hey, Liam, we don't allow privileged containers inside our environment. And there's no denying that pull request and that review process is really important. However, when we're thinking about, excuse me, when we're thinking about enabling that enforcement at scale, we need a line of defense at the deployment time. So yes, we'll do that pull request. Yes, we'll do that review, but we need that guardrail in place that's going to prevent me from doing this as a last resort. So let's go and have a look at that experience. If I go ahead and apply this to the cluster, kubectl apply pod, it's denied. The first thing that happens is that policy admission that we saw in the diagram previously has denied this request into the API server. And it's giving us some detail as well. It's giving us some guidance that's going to help us navigate remediating and resolving this particular issue. So it's first of all telling us that it is the gatekeeper admission webhook that has denied this request. And because of that, we know straight away that there is a policy violation. It's then going to tell us which constraint it is that we failed on. So it's telling us that it's Azure policy, Kubernetes Azure v2 no privilege. So we know straight away which one of those policies that's been applied to our cluster is the one that's currently denying our request. We then get a nice error message, privileged container is not allowed, and it's going to tell us which container we are currently violating this request against. And then it's going to give us a little snippet from our YAML file, and it's going to say, hey, you've currently set the security context privilege to true, and this is why we've denied this particular request. So pretty helpful, pretty prescriptive, and it gives me all of the information that I need to very quickly unblock this particular issue and move forward. So over here on another screen, let me just quickly go and fix this. And we can just set our privileged security context to false. Let's have a look at that just to confirm. We can see that we've updated this pod definition. The security context is now set to false. And as such, we should now be compliant with the policies that have been assigned to this cluster. And that workload is now allowed. I can continue. I can continue to crack on and do what I need to do. And there's a couple of things here. Appreciating that this is a relatively simple demo and a very relatively simple workload, but it does help us illustrate and understand the mechanics of this process end to end. And for our security teams, we can enable, or we can build confidence, and we can build trust against our security requirements by allowing our infrastructure teams and security teams to define and assign policies to our cluster. And from a developer's perspective, I can crack on, I can consume that cluster, I can deliver against my requirements in a low friction way while having the confidence that I'm not violating policies. I'm staying within the constraints of the organization. So at this point, we'll jump back, and I think we're slightly ahead of schedule, but good opportunity for us to dive in and potentially have a look at some questions that might have come in at this point.
Okay, and so if there's any other questions from people live, then please get them in at this moment as well. We had another question come in earlier around the benefits of AKS can be used locally as well. And the answer is yes, but this policy sort of stuff, this is specific to Azure, right, Liam? And this is part of the wider, I guess, more of like a well-architected approach that people often take with Azure and applying policies. I wanted to jump into one question that we have, and here we go, from Vic. So is there a way to manage exceptional scenarios of allowing a specific pod/workload to run privileged containers?
Is there a way to manage exceptional scenarios of allowing a specific pod/workload to run privileged containers? So there's a couple of things here, and Vig, please jump in if this doesn't necessarily answer the question directly. But there's two things that come to mind. First of all is if we have this kind of blanket policy in place that doesn't allow privileged containers, then no, there's no workaround here. But Azure policy does give us the ability to put exemptions in place. So we can refine these policy assignments down to a particular namespace within the cluster, where perhaps we have a privileged namespace where these privileged containers are allowed to run. The other thing that comes to mind is if we do have a cluster where we are allowing privileged containers, what other controls can we put in place to refine and to control what that privileged container is allowed to do? So thinking about things like AppArmor and secure computing and creating kind of a tailored profile that uses the principle of least privilege to define exactly what that privileged container should be allowed to do and what it's not allowed to do. So this is kind of outside the scope of Azure policy, but there are other controls that we can put inside the cluster on the nodes that in the event that we do need a privileged container, we can still control what it should and shouldn't be allowed to do.
Cool. So in your example, Liam, you showed us about privileged containers, but what if there's other scenarios that people have? So do we have the opportunity to create custom policy for Azure Policy for AKS?
Yeah, absolutely. I think I focused a lot on the privileged container, but it's worth mentioning there are lots of policies available, right? If we jump back very quickly and just have a look at those definitions, we can create our own initiatives and we can assign a really broad range of policies against the cluster. Privileged escalation, ports on services, allowed host paths, and a lot more as well. Let me just bring that list back up while I answer the second part of your question. There we go. And we'll kind of just bring that list up. There are lots of policies available. I've simply just used the privileged one as it's a nice simple one to demo. But to the second part of your question, custom, yeah, absolutely. As policy administrators, we have the ability to publish our own policy definitions, our own constraint templates, our own Rego expressions that define things that we want to enforce within our organization that maybe aren't industry standard or maybe aren't common across different Kubernetes use cases. So yeah, absolutely, we have the ability here to create our own policies and to introduce our own validation requirements and use Azure policy as a vehicle for driving or rolling out that policy at scale.
With some of the policies that we'd be maybe implementing, from your experience, are there any really good ones that most customers might want to implement, maybe some best practice or recommendations on some common policies that you might know, Liam?
Yeah, absolutely. And I think a really good starting place for most organizations that are kind of just getting started with their policy rollout or policy adoption, particularly in the Kubernetes space, are these two baseline initiatives. For Linux workloads, we have the baseline standards and the restricted standards. Depending on your kind of appetite for risk versus appetite for flexibility and compatibility within the environment, both of these initiatives recommend kind of a really good starting point. This is your baseline. And we could have a look at the restricted one, for example. There are 8 policies within this initiative, and they are all arguably valid for 99% of workloads, whether it's requiring seccomp profiles, whether it is looking at not allowing privileged containers, all the way through to managing access to host paths and port numbers on services, etc. So I think if you're getting started, if you're not really sure what policies, what your baseline should look like, I would definitely recommend having a look at these 2 initiatives that are readily available to assign to clusters today.
Brilliant. And I think that ties into one of the comments that we had. So Vitos Dev asking, is there templates for policies? I think these are some good templated examples that you can start working with, right?
Yeah, absolutely. I think these are ready to go. That they're templated. They're ready for you to assign to clusters. If you're looking for a template for creating your own, then yeah, absolutely. We'll try and get a link dropped in the chat for where to find those templates for custom policies if you're looking to create your own policies there.
Okay, great. So one other question. Does Azure Policy for AKS replace pod security admission?
Okay, good question. I think, first of all, I'll answer what pod security admission is. Pod security admission is a native feature of Kubernetes, of the upstream project. And it is there to provide a native way within Kubernetes to enforce pod security standards. So pod security standards, there are 3 of them within Kubernetes, and each of them move across that kind of scale of appetite for risk versus appetite for compatibility. And pod security admission is essentially a built-in admission controller that enables us to enforce these standards inside the cluster without additional components like Azure Policy, without additional components like Gatekeeper. And for single cluster implementations, and particularly for small organizations that are kind of just getting started with maybe 1 or 2 clusters, pod security admission is a fantastic way of establishing a baseline very, very quickly. We enable it on the namespace, we enable it on the cluster, and very, very quickly we have this kind of industry standard baseline of the pod security standard. The challenge that we have with pod security admission is operating policy at scale. And when we are looking at tens, hundreds, maybe thousands of clusters within our organization, and we need that all-up view and a way to manage policy across the landscape, across the organization, then this is where pod security admission falls short a little bit. And actually leaning on something like Azure Policy for AKS gives us that single point of control and single point of management for policy across the entire organization. So I would say no, not directly. That there's definitely scenarios where organizations will use both. We'll use pod security admission to give us the baseline inside our cluster, and then we enrich that baseline with policies from Azure Policy for AKS. There's definitely organizations where pod security admission is enough, and that's enough for them. But typically, as we start to scale, we want to start leaning on some of these kind of enterprise management tools, such as Azure Policy for AKS.
Okay, brilliant. So there's kind of one more comment to get to, unless any others come through live in the next few seconds. But a bit of a comment from KL Pause 82 said, Liam, explanation is very clear and clean explanation. He doesn't actually have any questions himself, but he's really looking for an idea of some homework and where to go to learn more. So I guess wider for everyone watching today, do you know any good places that people can go ahead and do a bit of homework off of today's session?
Yeah, absolutely. There's some really awesome material out on Microsoft Learn that gives us an opportunity to understand both the adoption journey for Kubernetes within our organization, and also the adoption journey for policy within that landscape. I'll see if we can get some links in the stream while we're wrapping up the session for some material. But I would absolutely recommend go check out Microsoft Learn, have a look at some of the learning paths on there for both Kubernetes and for Azure Policy, and that's going to be a really great place for you to start. If you're looking for some homework, not many people ask for homework, but if you're asking for it, if you've got Kubernetes in your environment today, I would encourage you to go and have a look at Azure Policy. Go and have a look and see what guardrails you can introduce and the compliance status that you can get to. It's low risk, we can have a look at our workloads, we can have a look at introducing a couple of policies and see how you get on. That's probably where I'd recommend starting.
Great. And just to add to that, if you don't have Kubernetes currently within your organization, or you're looking to help find like a good starting point, I definitely recommend some of the work that Liam has been doing recently, along with many other members of the UK, the CSU. So, for example, AKS construction is where to search to go ahead and get started on all things AKS as well. There's plenty of templates and a good UI experience that you can go ahead to get your sort of first clusters up and running with Azure Kubernetes Service.
Yeah,
Okay. Well, thank you so much for joining today, Liam, for running through that session with us and for doing those demos. I've learned a lot. I hope the wider audience has learned a lot as well. We did get one question just come in right at the end.
Yep.
From Gordon. Can you recommend any Azure policies for cost management in AKS?
I can think of lots of custom policies that we could introduce for cost management. The one that comes to mind here is the right size or right sizing our workloads, making sure that the containers and pods within our clusters are consuming or being allocated the right amount of resources. And one of the policies that we can roll out in Azure policy for AKS is the enforcement of requests and limits. So within a pod, within a container, we can specify how much CPU and how much memory we should allocate to these particular containers. And by enforcing that, we enable the Kubernetes scheduler to do a better job at scheduling the workloads in the cluster, do a better job at that bin packing and making sure that we're really optimizing the density of resources in the infrastructure. So I think that's probably one example that comes to mind, probably a good example that can really help drive the cost down in the cluster. Not necessarily directly, but there's an indirect effect of that when we start optimizing the scheduler's ability to maximize resource density.
Okay, brilliant. Thank you. And we've just shared a link into the live chat as well for some of the Kubernetes learning and training that Liam was mentioning earlier. So thank you once again, Liam. Thanks for joining us. And
no problem at all.
We shall hopefully see you again soon.
Yeah.
Okay, so a couple of things to wrap up with is we want to focus on, again, learning. So we've got the Cloud Skills Challenge in the UK. So this is a collection of modules on Microsoft Learn that you can go ahead and go to. So the link is here on screen at ak.ms/lunchbytes/CSC. And if you're interested in the developer side of things, then please check out our UK Developer Hub as well. And if there's any other questions or you'd like some future topics to be covered by us at LunchBytes, then please feel free to drop us an email at lunchbytes@microsoft.com. Now, if you're interested in some in-person meetups as well, then certainly go ahead to aka.ms/UK community, where you can find your local community talking from a range of different topics. So some things would be Azure AKS specific, or we may even be more sort of Visual Studio, .NET development, that kind of thing. And so again, please do check out the links on the slides to go ahead and do that. And I'll hand over to Annika.
Thank you all for joining today's video. We have in the next 2 weeks, on the May 31st, we have Owen, who's going to come talk to us about AKS Zero Trust Security. He is also a cloud solution architect working at Microsoft, and I think that'll be an exciting one. So hope to see you all there. Thanks you all, and yeah, see you in the next 2 weeks.